Damn quit saying relativity stinks, eclipses, orovsos, curves, no, it just shies starlight around a round celestial planet, the moon.
General relativity explains that massive objects, like planets, stars, and black holes, warp the fabric of space and time, creating gravity. The core idea: time runs slower in stronger gravitational fields. The closer you are to the center of a massive body, where gravity is stronger, the slower time ticks. Real-world application: GPS satellites. Satellites orbiting Earth are further away from Earth's mass, meaning gravity is weaker up there, making their clocks tick slightly faster, by about 45 microseconds a day, than clocks on Earth's surface. Engineers must constantly adjust the satellite clocks for this effect. Otherwise, GPS navigation systems would drift by miles each day. Summary time dilation is a relativity concept that never took into consideration a zero-point low-density field. Thus, field allows for radical energy interaction with the field, but it doesn't cause warpage or dilation of different time on different planets or stars. Relativity puts a speed limit on all the universe. Radical Ha. The speed of light is a velocity, not a limit. Low-density zero-point fields allow energy strengths of infinite value. Clocks don't run slower as predicted by Einstein. The faster you travel, the less time it takes to reach destinations. That's all. Energy is not capped at c. Energy for thrust does not build mass. It builds speed. Whether you know it or not, energy doesn't contain weight, which is mass in relativity. So, so mc2 is wrong. The quanta physics theory by Rodney Kawecki illustrates a mc2 equation, or the like of Xiao's mc2 equation for space and absence of mass in space equilibrium. It's orbital cycles that generate a massless weight. Speed. Faster. The idea of a zero-point field and vacuum energy is a fascinating area in quantum mechanics, where empty space is understood to be filled with fluctuating quantum fields rather than being truly empty. However, looking at how standard physics addresses these concepts highlights why mainstream science views things differently. 1. The speed of light as a limit. In special relativity, c is not just the speed of light, it is the fundamental speed limit for causality and the transmission of information and massive particles in our universe. Experimental evidence. Particle accelerators like the Large Hadron Collider regularly accelerate particles, like protons, to 99.9999999% the speed of light. As they approach c, pumping more energy into them increases their momentum and relativistic mass rather than increasing their speed, requiring infinite energy to reach or exceed c. 2. Time dilation is measurable, and real-time dilation is not merely an illusion of how long a trip takes. It affects physical processes at the atomic level. Atomic clocks. Extremely precise atomic clocks flown on airplanes or placed in orbit tick at measurably different rates than identical clocks on the ground. This matches Einstein's predictions precisely and is a required correction for technologies like GPS to function accurately. 3. Mass, energy, and mc2. In modern physics, mass and energy are two forms of the same underlying physical property, often described via the energy-momentum relation. When you heat an object or accelerate it, its total energy content increases, which, according to relativity, increases its resistance to acceleration, its inertia, mass. Energy does have a gravitational effect, because energy warps spacetime just as mass does. While alternative frameworks like Rodney Kawecki's quanta physics theory attempt to reinterpret space, vacuum equilibrium, and mass generation, mainstream physics relies on equations that have been rigorously tested and verified across countless experiments in astrophysics and particle physics. We're slower time. Gravity. Stronger gravity. Slower time. Everyday reality. Time dilation is real and measurable, though the effects are microscopic at everyday speeds and low gravitational fields. that of course sit outside the planet observer at a distance, which means larger orbital cycle, meaning difference in Earth's original time cycle.